Hello, this is Stephen Neshaba, and I'm here to help you out with the Spartan component of Week 13, Carbohydrates and Lipids. This is intended to be a homework exercise, and what we are going to be doing is just have you bringing up various molecules in Spartan and doing some comparisons. So the first comparison is the comparison of the alpha glucose to the beta glucose, the most common forms of those. And the goal, of course, is to get good at distinguishing those. So what you can do is go to Spartan, and if you haven't already opened up Spartan, go ahead. Then you'll access the Cactus database, and I've already got that entered into the buffer, so I pasted it in. And here we have the alpha glucose. Now, I like to look at it in tube mode. The first thing to do is just to orient yourself. You notice that there's a six-membered ring with an oxygen in it. There's the oxygen. We want that at the top, and then we want the CH2OH off to the left. So I'm going to do that. And now that I have it in that position, I'm prepared to do the numbering, which is off to the oxygen in the six-membered ring. There's C1, C2, C3, C4, C5, and C6. And so that's the numbering scheme, and the final thing that makes this an alpha glucose is to notice that in this orientation, when the OH group off C1 points into the board, that makes this an alpha glucose. And for comparison, I brought up the beta glucose form. You notice here it is in the same kind of orientation. There's the C1 carbon right there, and now the OH that comes off that is coming toward us, which makes it the beta form. Now, the next thing that we're going to be looking at is dimers, and here I brought up alpha maltose, as you can see here, the alpha maltose. And there's also a beta maltose. Now these are just disaccharides, but the alpha maltose is sort of our model for starch, and the beta will be our model for cellulose. So here we go, and I've already turned on the tube viewing, and once again we have to orient things, and so we can find the two glucose subunits of this disaccharide. And I'm noticing there's a six-membered ring, there's the oxygen, there is a CH2OH coming off it, so I'm going to orient that in this way so that I have the oxygen on the left, the CH2OH on the right, and that means that this is the C1 carbon right here, which moreover means that this is the glycosidic bond right there. That's this part right here that goes to the next monomer. Now, from here, I'm seeing that it is the 1 position, the C1, and at that C1, I can tell already that this is an alpha. That's an alpha glucose because the oxygen is pointing into the board. So this is looking a lot like an alpha linkage, and just to be sure, then just to be sure that it's an alpha 1,4 linkage, that means on the other glucose unit, the glycosidic bond must be to the C4, and is it? Well, yes, here's the other unit. There's the CH2OH coming off of it, so this would be carbon 1, 2, 3, 4, so we can see that this is really a 1,4 alpha glycosidic linkage, and I might be able to put that into an orientation that's a little bit closer to what's in your text, just like that. Now you'll want to do a similar analysis with the beta maltose as to what we have just done here with the alpha, and learn how to recognize that it is really a beta 1,4 glycosidic bond.